Alright, 3.1 transversals. Here is 3.1 notes. So let's start off with the objective. Students will be able to identify angles formed by two lines in a transversal and to prove and use properties of parallel lines. A transversal, this is a line that intersects a pair of coplanar lines at I should say at two, didn't really give myself enough space here, at two different points. So here's an example right here. I have two lines that are on the same plane, intersected by a transversal, and it intersects at two different points. And these all create a whole bunch of different types of angles. The first kind are called alternate interior. And so the example there is 3 and 6. These are alternate interior. So let's fill that in. These are two angles that are on the alternate, or you could say opposite, sides of the transversal, and inside the two coplanar lines. That's why they're called alternate interior. And we could say, for example, here 3 and 6 are alternate interior angles. Could you name another set of alternate interior angles? Now, if you take a look, 3 and 6, right, they're on opposite sides and inside these lines. Well, 4 and 5 are also on opposite sides and inside these two lines. So you would say angles 4 and angles 5. I'm probably not going to be able to keep that drawing on there, but I'll try as long as I can here. Alternate exterior, these are two angles that are on the, again, alternate or opposite sides of the transversal, and now they are on the outside of the two coplanar lines. So our examples here are 1 and 8 are alternate exterior angles. So if we look at 1, we look at 8. They are outside these two lines and on opposite sides of the transversal. Okay, 1 and 8 are alternate exterior. Can you name another pair? Well, if 1 and 8 are alternate exterior, so are 2 and 7. So angles 2 and angle 7. Okay, I'll just have to scroll back and forth to the picture. Same set interior angles. These are two angles that are on the same side, you got it, of the transversal and inside the two coplanar lines. So, for example, angles 3 and 5. If you look up here, 3 and 5, they are on the same side and inside these two lines. So another pair would be 4 and 6. They're on the same side and inside these two lines. So we could say, yes, 4 and 6, angles 4 and 6. All right, last one is corresponding. And corresponding is kind of nice because corresponding starts with the letter COR. What also starts with the first three letters COR is corner. And corresponding angles are always in the same corner. So let's take a look up here. The example they gave us real quick is angles 1 and angle 5 are corresponding. So look, here's angle 1, here's angle 5. What I tell people is, let's just say we're going to block out those angles, so we just have one left. Well, 1 is in the top left corner, so block out all the other angles, and look, 5 is in the same corner. And so we got that angle 1 and angle 5 are corresponding. There we go. So, if 1 and 5 are corresponding, could you tell me what else is corresponding? Like, what angle is corresponding to 2? Well, 2 is in the top right corner and 6 is in the top right corner. So, what angle is corresponding to 7? If you look, 7 is in the bottom left. So, what is in the bottom left? Well, it's 3. Okay, so hopefully you got that. And we could just name another set real quick. So, let's just say 4 and 8. That's what we'll name in our notes because those are also corresponding. So we say angle 4 and angle 8. There we go. It looks like something happened to this practice problem, so I'm going to go on to the next page. Maybe it'll be on there. Yeah, it looked like this example kind of got messed up, so I'm not going to be able to really do that one with you guys, but I'll try practice number 7 with you guys, and then we'll be done. Okay. So name the pair of lines for which each line is a transversal. Well, in order for it to be a transversal, remember it needs to intersect two lines at two different points. So we could say that line D here is a transversal for lines T and R. Can you see what other pair of lines it is a transversal for? Well, here's T, here's R, intersecting at two different points. But we also have Y and R, and that's intersected at two different points. So D is a transversal for Y and for R. So we can add that. It's also for Y and R. And line Y, well, line Y intersects also T and R. And if you look, it also intersects D and R at two different points. So that's an answer as well. How about line T? Does line T intersect two lines at two different points? No, it does not. It intersects D and Y, but it does it at the same point. So we don't have an answer for that one. And lastly, line R is over here, and it intersects lines D and lines Y at different points. But that's it. So that's the only answers there. If you want, you guys can try and see if you can figure out the names of all these angle relationships here, 2 and 3, 7 and 12, 9 and 16, 1 and 14, 1 and 11, 6 and 9. And another one to try is angles 9 and angles 11. And if you want to do that, use the drawing from the page before it, and you should be able to figure that out. Okay.